so me, I have experience in process engineering, informatics. I've been in the IT field for over 20 years. And currently, and I've also been in blockchain for 6 years. And that's a pretty long time because blockchain is kind of new. I think Bitcoin is like, what's it, 10 years? About 10 years. So I met a lot of the, I actually met a lot of the guys that actually created a lot of this technology. So I was able to see a lot of the evolution and the old technology and how it evolved and what the benefits are for how it is now. So I was just going to go over a little bit about that. So what is blockchain? Okay, I'm going to use these technical terms that you probably heard before, and I'm going to explain them for, so it's an immutable, secure, open source, transparent ledger. That's a mouthful, right? So what do I mean by immutable? That means that when you put a transaction on there, it can't be tampered with, right? And some use cases for that would be, let's say like in the supply chain, chain of custody, right? If you're tracking a product, what happens to that product as it goes through the supply chain, right? The customers want to get that product and exactly the product that they bought, right? So there's use cases for that, right? And in the technology, if you talk about informatics, version history, keeping version history, and you're talking about databases, this is a new way to keep version history, right? And then you talk about security. How is it secure? Well, blockchain is secure by using a consensus algorithm. And the first algorithm that was used is proof of work, and that's probably heard of Bitcoin, probably heard of Ethereum, right? So basically how that works is you have all these miners, and what they're doing is a brute force attack on a block to basically what they're doing is decrypting a message. And when they decrypt that message, that verifies that transaction belongs on that blockchain. Mm-hmm. Now that algorithm is really expensive because it takes a lot of electricity to actually do that, and it's very slow. So if you have any experience with Bitcoin, you'll see transactions at a point in time it takes 10 minutes or even longer to actually get a transaction through, right? So there are some issues with the first technology, and that's why it's evolved over time, right? So the technology that we're using right now is EOS, and it's based on what you call distributed proof of stake. So instead of having all these miners waste all this electricity to actually verify a transaction, you have these block producers that basically they collaborate in a schedule. And this block producer produces this amount of blocks, and so it's kind of like a schedule, right? So it's more efficient, and also you can have free transactions. And that was something I didn't mention about the proof of work. The proof of work, the transaction costs money, right? So imagine a application like Facebook, right? And a person is commenting on Facebook. Every comment they put in Facebook, they have to pay a fee, right? Can't design applications like that, right? Imagine like a high-speed trading system, right? That has to cancel orders, change orders. Mm-hmm. Every transaction costs money. No, that's not going to work, right? So they had to evolve to a system where you can have free transactions, right? So that's EOS.
And quite a bit quicker.
Oh, and speed as well. So you can do transactions 10,000 per second, but they're scaling that up to 40,000, and it's probably going to even be faster than that right now. And I think Visa is around 10,000, so that's pretty good.
And it's half-second block times as well. Instead of the 10 minutes, that 6 confirmations into an hour, you can get a transaction in half a second, which would be nice. So you can have interactive applications you couldn't have otherwise.
Now let's talk about open source. Now that can be scary for companies, right? Open source, and we have software we develop, and we don't want anybody to get the code, right? So when I say open source, we're talking about the infrastructure, right? So you can actually use the infrastructure that's in place, that's being maintained, right? And you can lower your costs in the infrastructure, right? So that infrastructure itself is open source. You can look and see what code is actually running that infrastructure, right? Now you could develop proprietary closed source applications on top of that infrastructure, right? So that's what you're going to know. Transparent. That means I could design a system where every transaction or data I have in is transparent, so the public can see that, and that may be important for, let's say, say like use cases of regulations, for instance, right? And you want things to be transparent, like accounting processes or something, right? So if you have a public-owned entity, like we're talking about the DAX, right? You want things to be transparent, right? So that's, but there's also technology in place where you can also have private data stored on the blockchain as well. And the use case for that, the use case would be healthcare, for instance, right? You have patient data, right? That has to be private. So you can have transparent, and you can also have privacy as well. And then when I say ledger, just to make sure everybody understands what I mean by that is, so just for any, I would say, say entity or so like this is like a balance sheet, right? For that balance sheet, you have a whole bunch of transactions that make up that summary sheet, right? Well, I want to be able to look at the current state. I don't want to have to manually count up all the transactions, right? So just like an Excel spreadsheet, you could do these calculations and look at. You could have the current state, right, and then it could update the current state. So that's another thing the blockchain can do. So summary, you can save money by reducing your infrastructure costs, right? And then also with the applications you develop, right, you can incorporate tokens inside of those applications to encourage users to interact with that application. So,
yeah. I think another thing that might be interesting to add is that global consensus you get with that blockchain, where it's like if you've got your private database, you're not going to give somebody access to your database to verify what you said you're going to do. You gave out those rewards that say you do the way you said you were going to, but that globally accessible, transparent database that they know is immutable by the very technology itself, it can't be modified, it's cheap basically, is a really powerful thing, because if one person changes and adds a new transaction somewhere over here in the world, everyone else at the same time gets a copy of that change. So everyone has consensus, everyone has the same view, the same information. It creates a lot of incredible synergies. There's some really amazing game theory dynamics and other aspects of economies that change when everyone plays by the same data. It's really fascinating.